So let's start with the case study 1, which is focused on the spam blacklist technique. In the spam blacklist technique, we actually prepare the data set by applying 2 steps. In the first step, we do stemming. Stemming is actually the process of removing morphological affixes from the words to have a more consistent email corpus. So what we do is that we, for example, reduce the word congratulations and congrats to the same stem words congrat. So we try to remove all the morphological affixes from the given set of email corpus. The second thing is that we also use some stopping words as well. So in the second step, the stopping words like the, is, are, or other stopping words as well, we remove it from the main email corpus as well. Now, the the spam blacklist technique is a bit not performing well. The first reason is that now let's take a look at the challenges that we are facing in this blacklist technique. The first challenge that we face is the inspection of the tokens in the blacklist. Many of the words in the emails, those words are nonsensical. So the Unicode, the URLs that are appearing, the file names, symbols, and many foreign words as well. Also, the spam blacklist technique does not work well because there are many words in the spam emails that are also frequently found in the legitimate email. And that is why the true negative or false positive or false negatives are very much higher for spam blacklist technique. And that is the reason that this simplistic algorithm does not work well, and the classification accuracy is just 69%, which is not good. Now let's take a look at the code of this case study